Conductor sizes. Understanding the limitations of conductors. As we saw with Ohm's law, resistance is key to a conductor's ability to safely deliver the amount of power that a circuit needs. Think back to the pipe. The bigger the pipe, the lower the resistance. Conductor material. When evaluating electrical supply, we need to recognize that copper and aluminum conductors are not the same. Although they are both commonly used in residential supply, copper inherently has less resistance to the flow of electrons than aluminum does. For this reason, aluminum conductors are always 1 to 2 sizes larger than the equivalent copper one for any given amperage. And speaking of aluminum, single-strand or solid aluminum branch circuit wiring should always be fully evaluated by a licensed electrical contractor. Multi-strand aluminum wires, as seen on service entrances and high-amperage circuits, are not a problem. This issue is presented in more detail later in the course. Large conductor size. As we have seen, for larger amperages, we need larger conductors. Please refer to the table within the How to Perform Residential Electrical Inspections course for a general guide to sizing conductors for feeders and services in single-family and dwelling units of two-family or multifamily dwellings. It cannot be used for other services or feeders for other applications. For a commonly installed 200 amp service, the service entrance cable, or SEU, between the meter base and the main electric service panel board with an integral main disconnect will have two 4/0 aluminum conductors for the HOTS and a bare 2/0 aluminum ground or neutral conductor. Please refer to the table within the How to Perform Residential Electrical Inspections course titled 2021 IRC Table 3603.1.1 Single-Phase Dwelling Services and Feeders that shows the sizes of service feeder cables, including common sizes 100 amp, 150 amp, and 200 amp service. Please refer to the table within the How to Perform Residential Electrical Inspections course titled 2021 IRC Table E3705.3.3 NEC 240.4D for overcurrent protection rating for small conductors that home inspectors can keep in mind. Looking at this table, we see that a 12-gauge wire, copper, is the minimum size for a 20 amp breaker. The wire gauge is permitted to be bigger than 12 gauge when connected to a 20 amp breaker. A 10-gauge wire is the minimum for 30 amp breakers. You can't have a wire smaller than a 10 gauge when it is connected to a 30 amp breaker. Overcurrent protection required. All underground branch circuit and feeder conductors must be protected by an overcurrent device. Overcurrent devices consist of circuit breakers or fuses. They are installed at the beginning point of the circuit where the conducts receive their electrical supply. The breakers prevent conductors from carrying current above the determined allowable ampacity. The breaker will automatically open the circuit and protect the conductors if the current is too high and may create a very high temperature hazard. For small conductors, commonly seen by home inspectors in residential buildings, the rating of the breaker must not exceed the ratings for the conductors. AWG stands for American Wire Gauge, which is a standardized wire gauge system. Key point: the maximum breaker rating must not exceed the allowable ampacity of the conductor. The smaller conductor sizes are normally single-strand conductors, but as they get bigger, they switch to multi-strand so they can be easily worked. It is unusual to see a conductor of less than 8 AWG to have multiple strands. A home inspector should look for single-strand, solid, aluminum branch circuit wiring, especially in homes built between the mid-1960s and the mid-1970s. The presence of solid aluminum branch circuit wiring in a home is a major defect. If you observe indications of such wiring type and deem it a defect, report it.